So just starting this recording again, and we're still on this page, and we're on example 5. So again, right, we know that the point is here, so I'm going to write the point is 0, 1. Right away I know that's x and y. This was the special case, right? And from the positive x-axis, positive direction, because 0 to 360. Again, get used to doing it this way, because this is kind of our standard way of getting the answers every time. So up, positive here. Yes?
Do we have to assume R is 1?
It's going to match here. So we do the radius is 1 because it's matching the distance here. So remember, this all came from that unit circle that we got all the triangles from.
It's always the Y?
It's going to match. No, it's not always the Y. It could, if the X was 1. So if I did the point here, so don't say always the Y, right? Yeah, it's whatever 0. It's here. So if I put here, if I put -1, 0, the radius is 1, right? If I did here 2, 0, my radius would be 2, yeah. But I never choose 2 because everyone's like, that's why they went to unit circle. They're like, I'm just going to choose 1 because then otherwise you get 2 over 2. You have to reduce it, so less reducing. Yeah, so try to choose 1. If I choose it for you by accident and I'm like, just tricking you, this is my point. Oh, sorry, 0, 5. I'm backwards. 0, 5. What would your radius be? 5, yeah. Okay, yeah. So it's whatever that value is.
So we use that in this, right?
Yeah, so I'm going to use, yes, from here to here, yeah. Okay, so we do need the radius. So from our special cases that we did last lesson, I needed this to be x, this to be y, r to be 1. The reason why we couldn't use the SOHCAHTOA, which we did above here, is because there's no opposite and adjacent, right? There's no triangle. So then we had to go to the original formula, which was this. That this was x, this is my angle, always on the bottom here on the horizontal, right? This is y heading up, and this is my r. Okay? From that formula, I can do my SOHCAHTOA. So we want the primary trig ratio. So for A, the primary trig ratios would be sine of theta equals, so now looking, okay, from here's my special angle, y over r, y over r. Yes, always between x and r. The reason why we got that, we're always looking at the angle between x and r, because our original, remember, our original diagram, this was our first triangle in the all quadrant. That's where our first formula, that's where life lived in grade 10, right? Life only lived in the first, nothing was ever negative. That was our good times right there, right? So now we're throwing them into the negative quadrant. So that's why. So we picture the original formula that was in the original first quadrant, and the angle will always between the x and the r. Sorry, I touched it. There we go. Then it's y over r, so I like to write the formula, so let's write the formula here so you can tell me what's happening. Then we're going to go to y, so 1 over 1, which will be 1 over 1, which is 1. Yes?
So when you do this one, the reference angle, like the dot,
yes,
is the same as like the angle of theta, basically.
Yes. Yes. Yeah. And then we'll find theta after. Yes. But my reference angle, yes. Yeah. So that's my reference angle. Yes. Yep.
So if it was always on like the line, like if it was 0, 2 or 0, like 3 for the coordinates,
yep,
would it just always end up being like 1 then?
Yeah. Sine will always be 1. Yeah, so that's why. And then we start to memorize those. So I told people yesterday, last lesson, right, don't memorize them because there's like 9 possibilities because there's every one of these, 1, 2, 3, 4, and 3 of each one. So it's 4, actually 4 of them plus the 0, so 5 times. Don't memorize, just picture it. And eventually I'm going to show you how to graph it so we can come back to this question after we do chapter 6, and then you'll see it. You'll be like, oh yeah, I can totally remember because it repeats. And you'll be like, yeah, so then I can memorize it even faster. So chapter 6 will come back here. We'll be able to do this question super fast. Yeah. Okay, so then let's do cos, because then there's a pattern, right? You're like, wait, every time I went around, there's a pattern, there's a repeat. Yeah, so exactly. So for now, they want you to use this because they did not teach you the graphing, so they want you to use the ratio. So cos is x over r. And then x is 0. So for now, I want you to show me the formula. Again, like I said, you'll skip steps later. Okay, you'll skip steps next year. I'll be like, yeah, don't show me that. Don't show me. I'll be like, no, I want. No, just kidding. You won't say. But yeah. So show me the steps, please, of what you're doing. All right. And then again, next year, as we get more familiar with it, you can show me less. This is over 1. So show me what you subbed in, just so I can mark it. Okay, and it's 0. And that way I can see all your steps. So don't skip right to 0. Yeah.
How is x gonna be 0?
X is 0 here?
Yeah, how is the first one? But, oh, we don't have triangle.
Yeah, there's no triangle. Yeah. So because there's no triangle, we had to go to formula base. The formula does work with the points. Yeah. Okay, so that's why. So we couldn't do the adjacent opposite, but the formula still developed from the adjacent opposite, so we can use the formula here to get to there. And there's no triangle, right? So this is why we couldn't use the opposite adjacent, because there's no triangle. Yes?
So that equation, like on the bottom, that
Yes.
triangle there, that's like, what, like, why are we using that as the equation? Is my question.
That comes from the lesson last time. So you want to just, that's where they developed the whole sign pattern. So they went, okay, it's always going to be on a unit circle, and they're doing the opposite in the radius, right? They came up with a pattern. So this comes from the whole pattern of sine, cos, and tan. And they found that it repeats itself once you have the same triangle. And then they tried it on the negative, and they went, wait, this is repeating. So then they came up with the whole cast rule. So this is really, the bottom line is you memorize that this is the original formula. So x is always horizontal, y is vertical, and that's the hypotenuse, right? And it comes back to the original diagram that we got, right? Okay, so then over here, y and x will be, and it works with this even though there's no triangle. So it's the weirdest thing, because you go, but there's no triangle. But the formula works the same way with the point even though there is no triangle. Okay, so then y is 1, and then x is 0. So please show me this. So I know that you might be like, I don't want to, I can just memorize it. Don't memorize it. Right? Don't memorize it. You want to understand where it came from. So this is undefined. And we talked about that last lesson as well. The 0 on the bottom is undefined. That's actually going to be, when we graph this, that'll be a vertical asymptote. And look, we learned that before when we talked about vertical asymptote. The 0 on the bottom. And when we graph tan in grade 12, you'll see that there's vertical asymptotes wherever there's a 0 on the bottom. So it kind of comes full circle with the whole graphing. So this is hard to explain, I find, without the graph. And then when you get to know the graph, it goes back and forth, and you kind of understand the whole thing better. So chapter 6, and then kind of connects it back. All right. So we've got the pattern. So hopefully we got the pattern. We say undefined. B, it asks you determine the angle. So determine the angle between 0 and 360. What's the angle? Starting at, remember yesterday, or last lesson, right here, I said you have to start on the x positive and head up when we're going in the positive direction. How do we go in the positive direction? 0 to 360. So that's saying go in the positive from 0 to 360. Okay, so what's the angle here? How do I get that? Yeah, it's 90. Don't do the inverse. It's 90. You can see it right away. Theta is 90. You can do the inverse of these, but again, why are you doing the extra work when you know it's 90? Right? So if it was 180, 270, etc., you know the angle. That's fine. Okay. Any more questions? Yes.
And theta is 90 because the line just goes straight up?
Yes. Yep. And again, the principal angle means that the starting point of the arm, the original arm, was here at 0, 0, heading out, and you're measuring the angle as if that was your vertex right here, and then you were sticking it here.